Hello everyone. We have a question of a modulus inequality, and the question is regarding finding the set of values. Reason, because we have an inequality, so definitely solution of this particular would be the set of values for the given variable, which is x. We have two different methods. The first one is the algebraic method and the other one is the graphical method. We would be discussing both of them so that we could get a clear cut idea what is actually going on. So let us start with the algebra. So the process is very simple. When you're dealing with the algebraic method, just go on by squaring both sides, and instead of this modulus sign, just use the round bracket, square both sides, and use the formula of a plus b whole square, which is a square plus 2ab plus b square, the same over here, a plus b whole square. And after that, rearrange them on one side, add the like terms like x square and x square, x and constant, simplify them, and you can see we have a proper quadratic equation. The condition says that this particular quadratic equation is less than 0. The second step is to find the critical values. Critical values, the value means the values of x on the x-axis, and definitely when we say on the x-axis, we know that the value of y is 0, and definitely this 0 is basically representing the value of y, because the critical values or the x-intercept would definitely decide the set of values. So first of all, let us go for quadratic equation so that we could find the critical values. Just use the quadratic equation. Use the values of a, b, c, which is a is 5, b is positive 26, c is positive 24. Place it in the quadratic equation, simplify them, get the two critical values, which are minus 6 upon 5 and negative 4. And because the quadratic equation have a constant positive 5 for the x squared term, so definitely because it is a positive 5, the graph will be a U shape, and this minus 6 upon 5 when converted to decimal is minus 1.2, which is definitely greater than negative 4. So this one is minus 6 upon 5 and this one is negative 4. Because in the question we have a modulus on just one side and the other side does not contain a modulus, so in this question the process is a bit different from normally the questions that have modulus on both sides of the question. If we just look at this particular question, you can see that the modulus is on both sides. When the modulus is on both sides, the process was same, squaring, quadratic formula, getting the critical values, and by looking at the graph, if it is greater than 0, definitely y positive, these would be decide the set of values, and if it is less than 0, negative, and definitely this area would decide the set of values. We are done. That means if in the paper the question comes and you see a modulus on both sides, simply follow these steps from the graph. You could easily observe, write the set of values, and you are done with your final answer. But if you have a question where you have a modulus on just one side and the other side doesn't contain a modulus sign, then you cannot judge from here what would be the set of inequalities. Then you have to go for a further process. The further process is also simple. You have three areas. One area is less than negative 4. One area is between negative 4 and minus 6 upon 5, and the third area is greater than minus 6 upon 5. So I have written minus 4, which is one of the critical value, and minus 6 upon 5, the second critical values. As I said, I have three areas. Just take any values which lie on in those three areas. That means I have taken negative 5, which is less than negative 4. I have taken negative 2, which is between negative 4 and negative 6 upon 5. I have taken 1, which is definitely greater than minus 6 upon 5. Use your question. Place these values, the negative 5, the negative 2, and the positive 1, in your main question and solve them and check out the answers, whether they are true or false. For the first one, when we took -5, it was seen that the answer was -10 is less than 9, which is definitely true. For when we took x as -2, it was seen that -1 is less than 3. Definitely it is true. But for the third one, when we took x is equal to 1, it was seen that 8 is less than 3, which is totally false. So that means the area which are in this true region are basically the set of values. That means this area is not the required answer. That means an area which contain 1, that means any area which is greater than -6/5 is not your answer. And because these both are representing a true condition, that means we can say that all the values which are less than -6/5, when we say less than -6/5, that means it contains this -2 as well as the -5 as well, because they are less than -6/5 and they are giving a true condition. That means all the values which are less than -6/5 are basically the set of values for the given. So this is something extra work that we have to do when we just have a modulus on one side. But if we have a modulus on both sides, I have shown you that what we have to do. If we have a modulus on both sides, you don't have to go for that process. You could simply from here get the two critical values. Based on this particular inequality, you could easily decide what will be your required set of values. If it is greater than 0, greater than definitely these areas, less than these areas. But for this particular, when we just have a modulus on one side, definitely we have to go with this extra process so that we could get the exact answer. The second method is the graphical method, because on both sides we have the linear equations. This is a linear equation and this is a linear modulus equations. Just take some dummy values for both of them and solve them to get the values of y. So we just took some dummy values like x -2, -1, 0 and a positive value, the same over here for both of them, and generated the values of y, because over there was no modulus sign. Therefore we had one negative value, and that means we can have negative values of y. But over here, because we have a modulus sign and we know that the modulus is never negative, the modulus is always positive or 0. The minimum value of a modulus is 0 or a positive. That is why you can observe that all the values of y are positive. If we draw the graph of these two, it is observed that they are straight line, first of all, because definitely they are linear lines. Secondly, this graph y is equals to 3x plus 5 is basically this line, which is drawn by a green color, and definitely over here there is no modulus sign. You can see the graph is also drawn below the x-axis, because we could have a negative value, as we can see when we took x as -2, we have y as -1. But when it comes to modulus, you can observe that the graph of this just touched the x-axis and bounced back. It did not go below the x-axis. Why? Because below the x-axis y is negative and modulus is never negative. That is why the graph of this one would simply touch the x-axis and bounce back, and touching the x-axis means over there the value of y is 0. If you look at both the graphs are intersecting at one point, and that particular one point is -6/5. And we have two different conditions. If we take any value greater than -6/5, it is seen from the graph that the green line is above the red line. And if we take any value less than -6/5, it is seen that the red line is above green line. When we say the green line is above red or the red line is above green, that means over here we can say that this green line is greater than this one, and this green line is basically the graph of y is equals to 3x plus 5. That means this 3x plus 5, which is green, is greater than the red one. That means 3x plus 5 is greater than modulus 2x plus 1. Is that true, that 3x plus 5 is greater than this one? If we just look at the graph, 3x plus 5 is not greater than this modulus 2, it is less than. That means any value greater than minus 6 upon 5 will not be an answer. And if we just take any value less than minus 6 upon 5, that is, the red line is above the green and this red line is modulus of 2x plus 1. That means over here we can say the modulus 2x plus 1 is greater than this one. And if you just observe the question, the modulus 2x plus 1 is greater than 3x plus 5, or in other word we can say that this green line 3x plus 5 is below this one. That means this 3x plus 5 is less than 2x plus 1 modulus, and definitely the question is the same, 3x plus 5 is less than this one. So finally the set of values, by looking at this graph and observing it, we can say that the set of values are x is less than minus 6 upon 5, which states true if we go for the algebraic method or the graphical method.